Hi, welcome to Turkish Engineering. In this lecture, we are going to study uniform circular motion, and this is the last part for the chapter 3, which is the kinematics of translational motion. So as we said, we have three types of translational motion, and the first part is rectilinear motion, and the second part is curvilinear motion or projectile motion, and the last part is uniform circular motion or circular motion. But circular motion can happen in two ways, which is uniform and non-uniform. Uniform means the velocity will be always constant. Uniform means our velocity always be constant. So what about the circular? In this case, our path is always circular, so it's not just projectile motion. In projectile motion, actually, I'm going this way and after this way, but this will not complete a circle. So you will see that this R will be different from this R. So actually this is not a radius of a circle. So the position and these distances are changing. So in projectile motion you cannot talk about a circular path, but you can say that it's curved path. It's a curved path, or it's just parabolic path. But in a circular motion, I will have just the same distance from each point. So we will just zoom to this circle to understand more about the velocity vectors and acceleration vectors. So let's just move to this one to the right side a little bit. Yeah, so this is my circle. What can I talk about this circle? Actually, we can have two types of circular motion, or two directions of circular motion. The first direction will be just what's that? So the first direction will be just counterclockwise, okay, which is opposite to the clockwise direction. And the second possibility to have just in the opposite of this one, so it will be clockwise direction. So I can move in clockwise direction, or I can move in the counterclockwise direction. What about this case? As you see, our velocity vectors show you actually in which direction you are moving. Actually, this is counterclockwise. So, as I said, our velocity will always be constant. So velocity is constant, and acceleration will be also constant. It is radial acceleration, and must be constant, okay? So, because we are talking about uniform circular motion, so acceleration, radial acceleration will always be constant, and velocity will always be constant. And as you see, we are talking about circles. So these distances, which is from center of the circle to this path, will always be constant because it's radius. So how can this motion happen? Just think about a car which is moving in a circular path. We'll start from this point. And as you know, in translational motion, our velocity vectors always must be tangential to our path. So as you see in this point, my tangential line will be just perpendicular to the radius line. So I have 90 degree here, and 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 I have 90 degree here. So always velocity and acceleration vectors will be just perpendicular to each other, and acceleration, radial acceleration vector will be always to direction of the center, and it will be just opposite of the radius, and velocity always be tangential. So as you see here, in this part, I have only upward velocity, which means I'm moving only in the y-axis. But this is just an instantaneous velocity. After a certain amount of time, I will reach this point. So I will have one component in x and one component in y. So this is the y component, and this is the x component. So you can say that we are sacrificing from our y component of velocity, and we are giving it to just x velocity. What I mean, actually, as you see here, our velocity in x is 0 because I'm moving only in the y-axis. But when you reach this point, this point actually, you will have a velocity vector in x and velocity vector in y. This velocity vector in y will decrease in this point. So you will have less y, more x. Less y, more x. Less y, more x. Until you reach this point, you will have maximum x and 0 y. So your velocity always just will be horizontal. When you reach actually between these 2 points, I'm just in this case, so I have maximum x and just minimum y, which is 0 y. So less x, more y, less x, more y, less x, more y, less x, more y. Until I reach this point, I have maximum y, which is downward, and minimum x, which is just 0. So as you see in this case, I have just 0 velocity in the x direction. So actually to see this in our real life, I must have certain amount of v. How can I calculate this value? And I must have certain amount of acceleration and certain amount of radius. For example, if our case for a circular path which has radius of 5 meters, this is a certain value, so I must have a certain amount of velocity and certain amount of acceleration, which makes me moving in this circular path and I will not go out. Actually, what happens in some car crashes in curved path, they are exceeding the velocity limit. I must have a certain amount of maximum velocity. If I exceed this maximum value, I will crash because I will just go outside of my circular path. But if I'm moving at the required velocity, I can complete my circular path without any problem. So how can this happen? Actually, I will zoom to two triangles. As you see here, R1, R2, I have a displacement vector here. So my initial position is in this point and final position in this point. So between these actually the 2 points, I have this blue line which represent our delta R, which means the displacement vector. Why my displacement vector is not the circular one, the longer one? Because this is just the distance. You are taking this distance, but displacement means the final position vector minus the initial position vector. So that means just the blue line, which is the straight line and a linear line, not a curved line. So I will zoom to this just this triangle. So I have angle theta, and I have the position vector 2 and position vector 1. This is delta R. This one is delta R. So actually this one will not be enough for me. This one will not be enough. I must come with, because it is just relations between R, I must come with some relations between the acceleration and between the velocity and displacement. So how can I draw a velocity vector triangle? Actually, I will start from this V1 and this is V2. So I will take them and make a circle, make a triangle. So let's see how can I put a triangle for two velocity vectors to see what's the difference between them. So as you see, I have just V1 which is upward and V2 which is just in this direction. So I must have this angle theta and these are equal to each other. How can I say that? As you see, the angle between R1 and velocity 1 is just 90 degrees. And the angle between V2 and R2 is just a similar one, which is 90 degrees. So you can say that when you rotate this triangle in this direction, just 90 degrees, so you will get this triangle. So the angles must be same. The angle theta here must be equal to this one because R1 is perpendicular to V1 and R2 is perpendicular to V2. So as you see here, I have a velocity change vector which is between these two vectors. So I will put a relation between these two triangles. As you know from the similarity in the triangles, when you take an angle and check the opposite one here, delta r, and take one of the length of the triangle. Okay, you can take this one and other one because they are similar to each other. R1 equals to R2 and V2 equals to V1. So this delta R divided by R, okay, this is seeing this one opposite to delta R is opposite to the angle theta. So I will put the opposite one to angle theta here. What is the opposite to angle theta? It is just delta V. So I will put delta V here. It is coming from similarity in the triangles. What about R? So it is just V because they are equal to each other and they are equal to each other. So I will put V. So from the geometry and from the similarity in the triangles, I can say that delta R divided by R will give me delta V divided by V. But this one is not enough. Actually, I have trouble here. I must put a relation between acceleration and velocity and R. So I will need acceleration will be equal to V times, for example, R or something like that. I must put an equation which just collect all three variables in here. So how can I put a relation between them? So actually delta V, how can I describe delta V? The velocity change is related with the acceleration. So you can say that acceleration always will be equal to velocity change divided by time, right? Because it is the rate of the velocity change. So delta V divided by delta T. And actually you can say just T because your initial time will be 0. So delta T will be just T. So when you just, instead of delta V, how can I put? When you multiply both sides by T, so you will get A times T will be equal to delta V. So here, instead of delta V, you can put A times T. So A times T divided by V will give me what? Delta R divided by R. But here, I must get rid of times and velocity because I need just acceleration here. So I will just multiply both sides by V over T. So V over T here. This V over T. So these will cancel each other. I will get delta R divided by T. I will put this T just below the delta R. You will see why I am putting there. And V divided by R. So actually this acceleration will be equal to delta R divided by T multiplied by V divided by R. What can you say about delta R divided by T? It is just the distance or the displacement divided by time. The rate of displacement per each time actually will give me what? Will give me the velocity because this is the velocity. So I can put here velocity. So velocity times velocity divided by R, that means it is just velocity squared over R. So congratulations. Here I came with a new formula which is just showing me what is the relation between acceleration and velocity and the radius. So I can say that if I know the radius of our circular path and I know the radial acceleration, I can say our velocity limit. So our velocity limit must not exceed this amount of velocity. So this is our general formula for circular motion. A will be equal to V squared divided by R. I will just put one idea after this one, which is time period. I will explain what's time period. Then we will finish this introduction video. Then we will be able to solve some problems for this one. So T means capital T in this circular motion will means just the period. Period means time passed to complete one revolution. Time passed to complete one revolution. So how can I know? This is actually talking about the time. So how can I calculate time if I know the velocity and displacement? As you know, velocity will be equal to delta R divided by time. So if I switch velocity by time, so time will be equal to delta R divided by V. So what is my delta R for one revolution? if I'm just starting from first point and coming to the same point in the circle, so I'm completing one whole perimeter. So one perimeter divided by velocity will give me the time, which is the time period for completing one circle. So it is just one perimeter formula, which is 2 pi r divided by velocity will give me the time period. Sometimes you don't know what is the velocity. For example, just think about a clock. You don't know what's the velocity of the clock, but you know that to complete one, this will be just the clock arrow. So to complete a whole circle, it will take just 1 minute, and 1 minute will be equal to 60 seconds. So I know what's the time period, but in this case I don't know what's the velocity. So the relation between the velocity and the v, which is the velocity, the relation between the velocity and the time period will be just this equation. So if I know time period, I can calculate the velocity, and if I know the velocity, I can calculate the time period. So time this will be just the general formula, which is 2 pi r divided by v equals to capital T. So this is just for this video, and we will solve some problems in the next video. So see you in the next video.